Hey, ladies and gentlemen, welcome to the Bermination Station. We are talking about Lesson 3.3. Lesson 3.3 is on the rate of change in slope. This will be somewhat of a review from last year's information. So let's get it cracking. So our big job is to be able to find out if we can find the slope from 2 points. So those 2 points might be on a graph, or they might just be 2 points that we just look at and find the slope from. So remember that slope is the rate of change. It is the rise over the run. It's the vertical change over the horizontal change. So the easiest way to do this is if we have 2 points that are graphed is to just count. So if we're looking for the rise over the run, we see the farthest left point, and we're going to say, how do I get to the farthest right point? And I have to stay on the grid. I can't do this diagonal cutting that's going on here. So what I'm going to do is I'm going to count. 1, 2, 3, 4. I rose 4, and then I ran 1, 2. So it's a rise of 4 and a run of 2. 4 divided by 2 simplifies to a slope of 2. So that's how easy this is, folks. Remember that if you're going up, it's a positive thing. If you're going down, it's a negative thing. If you're going to the right, it is a positive thing, and to the left, it is negative. All right, so example number 2. Same exact idea, we're just going to count from one point to another point. So because we're the farthest left point to the right point, we read left to right. That's the easiest way to find these things. So I'm going to go my rise over my run. My rise is a negative 2 because I went down 2, and that's a negative thing to do. And then my run is a positive 1, 2, 3 because I went to the right 3. So my overall slope here is a negative 2/3. Now the difference from this slope and the example 1 slope is this one's going downward. That's how we know it's a negative slope. Imagine it like a bank account. If you had a graph of this as your bank account, you'd be super upset because it's going downward. That's a negative thing. If this were to be a graph of your bank account, it's a positive thing. We're happy. Yay, money. So same ideas happen on example number 3. So we're looking at the rise over the run. And in this particular case, our rise was nothing. So the number that it rose up was 0 spots, and the run was 1, 2. 0 divided by 2 gives us a slope of 0. Now the exact opposite of this is if we were to have a vertical line. Cool, I just made one. And our job was to find the slope between these 2 points. So the rise is 1, 2, 3, 4. And the run is 0. Anytime you type 4 divided by 0 into your calculator, or if you ask Siri what is 4 divided by 0, you get a pretty mean response from her. It's an undefined. You cannot divide by 0. Undefined. All right. Now, to make things more difficult, we're going to make you graph and then find the slope. So this is our attempt to make it harder. So to the left 2, up 1 is a dot. To the right 1, 2, 3, 4, 5, up 7, 1, 2, 3, 4, 5, 6, 7. We use the fact that I have a computer here to make things more nice and party. So there it's all nice and party-like. And my job is again to count. Uh-oh, what did I just do? Don't tell anybody else our little secret. There we go. I need to move it back though. Okay. All right, so our job is to count the slope here. So just like on the previous examples, we're counting from the left dot to the right dot. So we're going to go up 1, 2, 3, 4, 5, 6. So that's a rise of 6. And then a run of 1, 2, 3, 4, 5, 6, 7. And a run of 7. So my slope is 6 over 7. Similar ideas over here. I know that my face is probably in the way of this problem, so I'll get it out of the way. It's a beautiful face, though, right? My wife tells me that sometimes when I'm in front of her face. All right, so 2, 5. I go to the right, 2, up 5, 1, 2, 3, 4, 5. Put a dot. Ooh, icky dot. And then to the right, 4, 1, 2, 3, 4, up 7, 1, 2, 3, 4, 5, 6, 7. And you will notice on this one that I connect the dots with a blue line, beautiful blue, up 2, 1, 2. So my rise is 2. To the right, 2. So my run is 2, which simplifies to a slope of 1. So my slope on that one is a 1. Now to make things even harder yet, I know you're wondering, how can he make it harder yet? We're going to make you have a new formula. This formula is the slope formula. This is what we will use if we're trying to find slope when we are given only ordered pairs. Now, if you wanted to, while you're shopping at Kowalski's, you could bust out some graph paper and graph -2, 1, and 5, 7, and then draw a line and find the actual slope. An easier thing to do would be to understand this formula. So we have a y2 minus a y1, so we're finding the change in our y value, and we have a x2 minus an x1, which is us finding the change in the x value. So if I just label my first point as my x1s and my y1s, and my second point as my x2s and my y2s, I can just plug those numbers into the formula and get to work. So if we do that, everyone's happy. So 7 minus 1 is where our first y2 minus y1 happened on the top. And on the bottom was x2 minus x1, so that's 5 minus that -2. Now we all learned a long time ago that 7 minus 1 was 6, and that 5 minus a -2 turns into a big old plus sign, so it turns into 6 over 7. My slope is 6 over 7. Now the second type of problem over here, or second one of these, see if you can beat me done. Maybe hit pause and check out if you can beat me. I'm going to guess that you can't unless you do hit pause because I'm the Burma Nation. All right, so we're plugging the numbers in. Again, I'm just choosing this to be my first point, this one to be my second point because it's in order that way. So I'm going to do this 7 minus 5 stuff, y2 minus y1, over the 4 minus 2, which was the x2 minus the x1, which gets me 2 over 2, which is still equal to 1. And I want to let you know before we end this, this whole video stuff with you, most common mistakes that kids make, for some reason, is to do 7 minus 4, or to do 4 minus 5. If you write down what the y1 and the x1 and the y2 and the x2 are, all you got to do is plug it into the formula. Take your time and keep the silly mistakes at a minimum. All right, folks, it's the Burma Nation. We're signing off.